Hey, welcome to Teletype Talk, episode number 8. I'm your host, Joe. Today's a pretty exciting day. We've got a new firmware for the Teletype, version 3.2, courtesy of CS Bowling and Disco Head and 10. Thank you guys. This is awesome. Today we're going to talk about one particular operator, the NR operator, which is a numeric repeater. And the game plan for today, I'm actually going to divide this into two parts. First, I'm just going to show you how to use this scene, because I think the numeric repeater op is fairly complex, and I think some people might want to just grab this scene and use it. And then after that, we'll actually go through and build the scene for those of you that are feeling a little more ambitious and want to master your teletype. So this is the scene when it loads up. It outputs triggers on the first 4 trigger outs on the teletype. It also sends those same triggers out to the ER301 sound computer on ports 1 through 4, so you can use it either way. So the way it works, we've got this row 5 right here, which is just a counter. So basically we've got, one measure. 16th notes is, I guess, one way to kind of look at it. Above this, we have the visualizer, these top 4 rows, tracks 1, 2, 3, and 4. And right now they're empty. Below that, we've got this row, third from the bottom is for factor. The next row down is for mask. And then these 4 buttons at the bottom are for track select, 1 through 4. And then the other control that we've got here is prime. So prime goes from 0 through 31. So let's talk a little bit about how this works then. So like I said, we've got 4 tracks. I'm using it with the ER301, and I've got track 1 set up on a kick drum, a snare, a hi-hat, and like a clap kind of sound. So to get started, you would just want to set your metro to whatever rate you want this counter to run at. Set your tempo. And to get started, we'll just start with track 1. Right now the prime is on 0, and the factor is on 0. So factor is kind of a multiplier. We're multiplying by 0, and we get 0 back out, so we get kind of nothing in this track. But if I change the factor to 1, then what we're getting is the prime pattern for prime 0. If I turn this knob, now we're on prime 1. Here's prime 2, 3, 4, etc. So there are 32, like I said, of those primes there. Let's go back to the 0, 1. So the prime, like I said, is for all 4 tracks. It's shared between them. Each track has its own factor. I'm on track 1. So if I change the factor from 1 to 2, we're going to see something happen to the beats in track 1. So this goes up from 0 through 15 here at the end. So let's set that back to 1. I like that for kind of a 4 on the floor kick. And let's switch over to track 2, which I have a snare connected to. And if I set its factor to 1, you're going to see it's just a copy of what's on the track above it. But these are all independent, so there's kind of an alternating kick and snare pattern there with the factor on 4. Let's turn on the hi-hat, so I'll move to track 3. And I know if I use a factor of 15, I'm going to get a trigger on every 16th. And let's just talk about the mask a little bit now. So the mask is basically going to remove some of these triggers. Right now the mask is on 0, so that is basically no mask. If I move to mask number 1, you can can see it removed these triggers here, and then, you know, some at the end. If I move to mask number 2, that removed a whole bunch in the middle. And then mask number 3 removes them on both ends and kind of leaves some in the middle. Moving to track 4, we can just pick a factor for this and maybe set a mask for it. So these are all independent controls. Like I say, if you move through the different tracks, you're going to be selecting the factor and mask per track. And then prime affects all of them. So if I turn the prime knob now, it's going to have some movement in all 4 tracks. So I think that's really all you need to know to use this. Like I say, you can use the trigger out ports here, or you know, use the I2C bus with the sound computer. So enjoy, and thank you Disco Head for that. Feel free to download and check it out. It's pretty fun, I think, you know, learning experience, and pretty fun live controller too for creating beats. If you'd like to learn how the scene is built and a little bit more about the NR, the numeric repeater operator, then stick around. Alright, are you still there? Cool, those other guys are gone. It's just us, and now we're going to talk about the fun stuff. Okay, so let's see. The NR numeric repeater operator. Let's bring it up here. We'll do a Control F to find and help. I did an Alt H and a Control F. That's a new search feature in the help, courtesy of CS Bowling. And let's just do a search for NR. So we can see that NR takes 4 parameters: prime, mask, factor, and step. It looks like it will wrap around and supports negative indexing on masks. Here are the different masks values in hexadecimal. And we can see it returns 0 or 1. So that's pretty crazy, huh? I mean, a function that you supply it with 4 params, and basically it just spits out a 0 or a 1. So let's try it. NR and PMFS. Prime will set to 1, mask will set to 1, factor will set to 1, and let's step to 0. And it gives us a 0. Interesting. We'll set step to 1, 2, 3, 4, and there we finally get a 1 out when we go to the 4th step. So that's a pain. I'd like to be able to see what all of these prime values are, kind of visualize them without having to sit here and type every single time. So let's try to get that up on the grid so that we can kind of go through the patterns and you know, see what those prime patterns look like. So I think the first thing we need to do, we're going to use this param knob for the prime. Let's go ahead and set that up in our init script, and we'll do param.scale and 0 to 31. Those are the values that we can feed into prime. And I'll go ahead and hit F10 to run that script. And let's set up some visualization on the grid. So I'm going to start here on script 2. I will tell you that the first time I made this, I started on script 1 and ended up moving some things around. So I just know I want to start here, but that's kind of how Teletype development goes. What I want to do here on script 2 is pretty simple. I just want to loop through 16 steps and basically turn on some grid LEDs based on what that prime pattern is. So let's do a loop. from 0 through 15. These are going to be step parameters into the NR op. And we'll just go ahead and fire script 3. So 16-step loop running script 3 each time. And what I want to do here is I want to get my 0 or 1 values out of the NR op. So we're going to go ahead and take a local variable j, and we'll do NR. And let's see here. The first parameter is prime, and we're going to set that equal to param, which is going to be 0 through 31. The second parameter, I think was mask. I don't remember. We're going to hard code these for now. So let's just do 1 and 1 for the factor and mask. Actually, I can pull up help here, I guess. Mask is first. Okay. And here we were doing J, NR, and we were doing param. We'll do 0 for mask. We'll hard code factor at 1. And for the step, we're going to use I, which is our loop counter. So we're setting our local variable j equal to that, and that should give us, run through this 16 times and give us a 0 or a 1 in j. So next, let's, on each loop, we'll just set a light on the grid in the first row and the column based on the step. So we'll do if j, we'll do g.led, and the x position is going to be our loop counter, I, and the y position, we'll just put that at 0 to put it in the kind of the first row. And so if j is 1, we'll set the brightness equal to 7. And otherwise, we're going to set that brightness to 0. So gled I 0, 0. And I forgot my colon there. Cool. So now when we fire script 2, hopefully it's going to, run the NR operator 16 times for whatever the current value of prime is. Let's pop over to the grid view, Alt-G, and prime should be at 0. Let me go ahead and hit my F2 key to fire script 2. And so what you can see here is that, we've got this first prime pattern. So that's a nice visualization of it. That is prime 0 stores that pattern internally. If I go ahead and turn the param knob up a little bit to increase prime, and then hit F2 to run that script again, you can see it's modified the pattern, and now we've got a little bit different pattern for that prime. Cool. So that's great. Now what I want it to do, let's go back down to 0, just make sure we're still good. I actually want to have these first 4 rows all indicate the prime pattern at once. So we've got, this script right here, script 2 is doing a loop through 15, and let's kind of nest this loop. So I'm going to go back over here to script 1, and I think we're going to have to use a global variable for this. So I'm going to go ahead and use a. Just use that, and I'm going to set that equal to -1. And so now let's call our script 2 4 times, 1 for each track, and then so we'll do loop 0 to 3, and we'll just call script 2. So this is going to run 4 times, calling script 2. It's going to call it once per track, and then this is kind of a double loop, right? So script number 2 is going to call script number 3 16 times, once per step. And let's see here. So what I'd like to do at the beginning of script 2 is to increment a. We set it to -1, so at the beginning of the script, before we call the next loop, let's go ahead and do set a equal to a plus 1. Okay, so the first time we call script 1, we start a at -1. We come over here, it's going to increment it to 0, and then we're going to loop through script 3 with a equal to 0. And so really all I want to do differently here then, instead of kind of hard coding this y value, gled, xy, brightness, we want to change these to a. And that way they'll have different Y positions each time we go through. So let's take a look and see how that worked. We'll go back over to the grid visualizer. This time I'm going to hit F1 to fire script 1, which should loop 4 times for 16 steps, total of 64. And it should give me the same prime pattern in each of the first 4 rows. Let's change the param knob to some other prime value. Hit my F1 key again, and it looks like they're all lined up, whatever that prime pattern happens to be. So great, I think we've got a good solid running start here. So right now we can control the prime value. What I'd also like to be able to do is to control the factor and the mask. So I think what we need to do is create some controls down here on the bottom 3 rows for factor, mask, and then kind of a track selector. Let's see here. So I'd like to do that in my init script because I'm going to be doing it multiple times. Let's jump back over here. So we know we want basically 4 sets of controls, right? Let's pop back over here to the grid view. So actually what I want is I want a fader for the factor for track 1, and I want a fader in the same position for the factor for track 2, and 3 and 4. So basically I want 4 faders laying on top of each other in the same position, and then we're just going to kind of hide them and show them as you go through the tracks. And the same thing here from the second row from the bottom. I want a total of 4 mask faders, 1 per track, and to just kind of be able to hide and show the ones I want based on the button selection on the bottom row. So we know we want to create basically 4 sets of controls. Let's do a loop here from 0 to 3. And let's go all the way out to the end here, and we'll fire script number 8. And then we'll go to script number 8, and we will actually create these controls. Let's do the factor fader first. So that's the one with 16 values. So you may recall, I don't know if we've talked about this before or not, but you can actually create you can not only create individual buttons or individual faders, you can also kind of create multiple buttons or multiple faders with the same command. And with grid ops you can also create groups of faders or buttons. And the advantage to doing groups is that you can kind of specify a group number for that group of faders, and then you can kind of do certain things with those in bulk, right? So you can enable or disable them, basically take them off the screen and by their group number. So we're going to set these up as fader groups. That way it'll be easy for us to they're all going to be stacked on top of each other. It'll be easy to enable just the ones we want to see. So we're going to do a grid.group fader, g.gfd. And the first thing we need to specify is the group number. So we're going to do group I. Remember, we're looping through this. So this is going to be basically group 0. The next thing I need is an ID. So we're also going to give that an I. Next we need X and Y. So we'll start these at an X value of 0 all the way to the left. And for Y, we're going to go to number 5. So that's basically 6 rows down, right? We've got 4 rows of tracks. One of them is going to be our counter track. And then this next one is going to be the factor, so number 5. Next, we've got width and height. So we'll give those 1 and 1, just single. Actually, not 1 and 1. We want this first fader to be 16 wide, and 1 high. So remember, this fader will have 16 total positions on it. Next we've got the type, and I'm going to set that to a 0. A 0 is a kind of a coarse fader, so it really won't have, faders are capable of having a huge range of values on them. This one's just going to be coarse, and it's just going to have 16 possible values. We'll give it a default level of 7. That's just the brightness of it. And then finally we need to set the script that we want it to call. And the script that I want it to call is script 1. Basically, every time I change this fader, every time I press a button on this fader, I want it to recalculate those top 4 rows that show what our patterns are. Okay, cool. So I think that, would create the 4 faders on here, but we also want to, right now these faders are going to be kind of sitting on top of each other, right? So let's pop back over here to grid view. And if I run script 10 now, our init script, it actually did create 4 16 length coarse faders here, but they're all kind of stacked on top of each other right now, so it would be really hard to press the buttons on them. So what I want to do for these is actually hide them, most of them. So let's come down here and we'll do a condition in this, and we'll say if I is greater than, and I is our loop counter, if that is greater than 0, then let's do g dot group dot enable I and 0. So basically disable that group. So group 1 will end up being enabled because it's not greater than 0. Groups 1, 2, and 3 will end up getting disabled. So we should just have one fader visible at the time when we see this. So let's come back over here. Let's do a g.rst grid reset. I do that quite a bit when developing grid ops type of scripts, and we'll just go ahead and hit F10 again to run this. And if we pop up to the larger grid screen view, right now our factor is set to a 0, and if you remember from the, the demo, that kind of disables all the steps, right? We're multiplying by 0. Let's go ahead and cursor over here and hit spacebar to switch that to a 1. And so now we get, some things on here. Go ahead and hit 1 again. And so now if we change to 2, 3, 4, it's not really doing anything, right? Although it is, if we can tell from moving the param knob, it is recalculating based on the prime value. So what we actually want to do now is start to take this factor into consideration, right? So let's pop back over to script 3, I think is the one doing all the work, right? So here we're calculating the value of that. Let's see here. So right now we've got hard-coded 0 for the mask, and we've got a hard-coded 1 for the factor. So let's go ahead and insert a new line up here. And let's figure out, what the value of that, that fader is, and use that for our factor. So I'm going to grab a local variable here, k, and let's set k equal to g.fader.n, which is in grid steps, the value in grid steps of that fader. And yeah, I think that's all we need. Oh, no, we need to, right now we're going to hard code, let's see, I think that would be fader 0. Let's go ahead and take this, and instead of 1 for a factor, now we're going to plug k in here. We'll pop back over here, and now let's see if we change our factor to 2 and 3. then we're starting to, you know, get the factor applied. Right now it's applying to, you know, all 4 tracks based on that one fader. So we actually don't want it to apply to all 4 tracks that way. So rather than hard coding the fader ID, right now we're grabbing the value of fader ID 0. Let's actually grab the fader that we pressed. I mean, actually, it doesn't matter which fader we pressed. We want to recalculate everything every time, and that's what we're doing. So let's actually grab the fader for the track number we're on. And the track number that we're on, we set that to A. If you'll remember back over here, we increment A each time we step through it 15 times. So now if we go back to the grid view, hopefully that's just going to change my first track. You can see that you know, the other tracks have now disappeared because their faders they're not enabled. We can't change them, and their default values are 0, so they're being multiplied by 0. So this seems to be working well. So now I'd like to put some buttons down here on the very bottom row to actually be able to switch back and forth between these 4 faders that we have stacked on top of each other. Really, right now, only the you know, only fader number 0 is visible. So we can do this in the init script. Even though we're going to create 4 buttons, we don't necessarily need these to be in groups. We can just go ahead and create 4 buttons. So let's do g.gbx to create multiple buttons. We will go ahead and create them in a group, I guess. So let's make these group 5. We've already used up 0 through, I guess just 3. We'll go ahead and make it 5. And we want to set an ID on each of these buttons. The button IDs are different than the fader IDs. We actually haven't used any button IDs yet, so we can go ahead and start these at 0. Let's see, G button X. The next thing we need is the X value, and we know we want these to be on the bottom left. So we'll start these at 0, and that'll be the column, and the row number will be 7 down at the bottom. The width and the height, we're going to leave at 1, so just 1 pixel each. The next thing is the type, and we're going to make these zeros. Those are non-latching buttons or momentary buttons. We need a default level, and let's set that to 7. I don't know why, I just kind of like 7s there. And we need the, next we need the script that is going to be fired. I think our first unused script is now 4, so let's go ahead and use that. And then we need columns and rows. So we want 4 buttons. Let's do 4 columns, 1 row. Cool. So that should create the 4 buttons. We can go ahead and check that in the grid view. I'll just hit F10 to fire the init script, and we should see them appear down here at the bottom. Now the buttons don't really do anything yet, so we're going to need to set that up. The first thing you'll notice is that they're all, they all start at the same brightness, and I would actually like to start, kind of with button 1, or button 0, I guess, selected. Let's go ahead and do that in our init script as well. So we'll just set g.led at x position 0, y 7, and we'll set that up to a brightness of 15. And if I come back here, let's just do a g.reset, and I'll run my init script, and now you can see that this button, hopefully you can see it in the video, this left button is slightly brighter. All right, so let's rig these buttons up to do something. I had set these to run script 4, so let's go ahead and create script number 4. So this script should fire anytime a button is pressed, and what I want to do, I want to figure out which button we pressed. So let's set j equal to g dot button I. That's the button index, and these should be indexed 0 through 3. So we should be able to tell, which one is done. The next thing I'd like to do, right now we've got button 1 lit up brighter. I'd like to go ahead and turn all these buttons back to the same kind of medium brightness, 7. So let's do a loop 0 through 3, GLED, and we'll just do X value is I. It's going to be 0 through 3, Y value of 7, and we'll set them back to a brightness of 7. And so next I want to light up brightly the button that we pressed. So we'll do another G.LED. And this time we'll use J, that's the index of the button we pressed, which should be 0 through 3 as our X value. Still keeping 7 as our Y value, and this time we'll set it up to a brightness of 15. If I pop back into Grid Ops now, and I press the second button, it should light up, all the others should go off. Third button pressed, it lights up, all the others go off, and so forth back to 1. Cool. They still don't really do anything, but at least they light up properly. So now it's time to add some actual functionality to them. And what we want to do is actually go through and enable and disable those faders that are stacked on top of each other. So we'll do a similar thing here, and we'll do another loop, 0 to 3. And let's do g.group enable I 0. Yeah, so that should disable everything in that group. And now I want to actually enable the group of faders that of the button we pressed. So we can do a g.group .enable. And remember, J is the button we pressed, and we'll go ahead and set those to 1 for enabled. All right, let's see how well this works. So I'll do a g.reset again, and F10 to run my init script. We're on track 1 now, so let's go ahead and set its factor to 1. And then we'll move to track 2. And let's set its factor to 1, and 2, and 3, and 4. And we can move to track 3. And we can change its factor. And we can switch to track 4. And let's go way over here and turn that up. So cool. So I think all that's working really well. We're basically seeing the value of the prime multiplied by the factor for the individual track. The next thing I want to do is create the mask fader. So as you'll recall in the init script here, we're already doing a loop from 0 to 3 and calling script number 8. And in script number 8, we're already creating one of the faders, actually 4 faders, but 4 faders of one type. Let's go ahead and create the fader of the other type in here as well. So let's see. Let's insert a new line here. And let's create our other fader. Let's see, for this one, I'd like to actually give this some different IDs than the faders that are already there. So that we started with the faders, you can see here, and we just kind of incremented I for the index number. I'd actually like to give these some different IDs, so we don't overwrite the other ones. So let's set a local variable here. We haven't used J yet. And let's just set this to I plus 4. So that way, we won't be numbering these 0, 1, 2, 3. We'll be numbering them, 4, 5, 6, 7. We'll go ahead and grab another new line. And let's actually create the fader with the same type of command. So g.gfd. And this time we're going to use use I for the group. So they are going to be in the same group as the other fader that we created, because when we use those buttons at the bottom to switch between the different tracks, we actually want it to enable both of these faders, both the factor fader and the mask fader. So we'll use the same group, but we'll use J to give them different IDs. Let's see, we're going to give them an X value, starting value of 0. So we'll put them on the, line them up to the left. And then for a Y value, we want these to be in the last row from the bottom. So we'll put them in a Y value of 6. Let's see, the last one was 16 wide. The mask only has 4 different values, so we're going to make the width of this 4. And again, a height of 1. We're going to make it the same type of fader, just a coarse fader, so we'll give a 0 for the type. We'll set the default level equal to 7, just so that we can see something on the screen. And then we need to call a script. So we're going to call, the exact same script. We're just going to call script 1 again. Script 1 always recalculates, all 4 rows of patterns. And this next line here, because we're enabling and disabling groups, and both of these faders, both the factor fader and the mask fader are in the same group, it's actually going to, disable both of those faders. And kind of the same thing over here in script 4, because we're enabling by group, it's going to remove, enable and disable both of those, leaving only the one for the button that's shown. So let's go ahead and I'll hit F10 to run the init script again. Actually, let me do a g.reset just to kind of clean everything up, and then we'll run F10. And let's test this out and see how it's working now. So we're on track 1. I'll give that a factor of 1. And actually, we're just testing the mask now, I guess, to see if it's enabling and disabling properly. So let's set that to a mask value of 0, 1, 2. We'll flip over here to track, and it should reset back. And when we come back to track 1, it should recall. Let's just try 4 and turn that all the way up. Back to track 1, back to track 4. So it looks like they're saving and recalling properly. That's great. Exactly what we want. And then finally, we want to take this mask and actually apply that to the numeric repeater equation. So if we come back over to, I believe that's here, where we do NR. So mask is this value right here, the 0. Rather than hard coding it to 0, let's actually fetch the value of that fader. So we want to do g.fader.in, and we need to give it an ID here of the fader value that we want to get, and we want to do it per track, so it's going to correspond to A. But we also started those at 4, right? So we need to add 4 to that here. So this should be, for the mask value that we're inputting into, the mask parameter that we are feeding in R. We should be getting the track number plus 4, so it should be like IDs, 5, 6, 7, 8. Let's take a look and see whether that works. So let's let's take track 1, and we know that if we go out to value 15 here, it gets very large. Ooh, that did something peculiar. Oh, we've already got a high mask value on here, and we're working with track 4. So if we set that back to 0, that's no mask. We get beats on all of these. If we set the mask to 2, it changes it up a bit. The mask there, and finally the mask there. So I think that looks good. Let's see if this works on track 1. Looks like we've already got a mask there. If I take the mask off, we just get the kind of the 4 on the floor pattern, and set the mask there. That seems to be working great. So I think we've got it calculating all of these patterns correctly. The next thing we want to do is set up our counter and actually, figure out whether or not we need to send a trigger for each track, and send it if we do. So let's pop back over to the Metro script, which is currently empty. All right. So one other thing. So like when we press on these faders, it's recalculating on the fly all 4 tracks worth of patterns. But right now it will recalculate based on the value of prime, but we would actually have to run that script manually. And I want it to basically run when this knob is turned, right? I don't want to have to press any extra buttons. If I change prime, I want the tracks to update immediately. So let's do this. Let's do. I'm going to compare the value of param to something, and I think I'm going to use a global variable for this. And we'll just use x. So I'm going to say if the param value is not equal to x, we're going to fire script 1. And script 1 is what recalculates all of our patterns. And then after that, we'll set x equal to param. So basically what this is going to do, if x stays the same, then line 1 isn't really going to do anything. It's not going to run 1. And we'll just, set x equal to itself. But if this knob changes, for that moment right there, when we first run this script, the value of x and the value of param are going to be unequal. So it'll recalculate all of our patterns and then, kind of true it up, and x will be the same as param until we change the param knob again. So that's going to happen on basically every beat, right? Every Metro tick will potentially reevaluate the patterns based on the param knob changing. The next thing I want to do is actually light up the LEDs. So let's do that. Let's do a loop, 0 to 15. And let's do g.led. The x value will be I, our loop counter. We want to work with row, let's see, we used 0, 1, 2, 3. This will be number 4. And let's set those to 0. So basically we'll turn off all of those lights in row number, in the 5th row down. So the next thing, I'd like a counter that goes from 0 through 15. Those are basically our steps, the parameter that we send into NR. So I'd like something that, every time Metro ticks, it's going to increment. But, once it gets beyond 15, I want it to reset to 0. And actually a really good variable for that is the O operator. So the O operator, it's global. It sort of acts like a global variable. And every time you call it, it starts at 0. So if I say, O, it's going to give me a 0, but if I call O again, it's going to give me a 1. And if I call it again, it's going to give me a 2. So each time I access it, it's just going to give me a higher number. But we actually can set a maximum value on it. It doesn't have to count up forever. And we would do that in our init script. So let's go ahead and add that in here. And let's say O.max is 15. So now every time I call O, it'll give me an increment 1 higher until it hits 16, and then it'll reset back to 0 instead of giving me 16. back in my metro script, let's set t equal to O. So t is just another global variable, but it's frequently used for time types of storage, just because of its letter. So t is always going to give me a number 0 through 15. It's going to increment every metro tick. Now let's go ahead and do a semicolon operator here to save some space, and let's just do g.led. And let's see here, we're going to do t for our x position, so it's going to be 0 through 15, row 4. And let's see, we'll just set that up to a brightness of, let's just do 7. So now if I come back to grid ops, you can see I've got the counter going across there. Perfect. So here's something really interesting we're going to do with this script. If you've already downloaded it and looked at it, you might notice that we didn't really use any of the pattern values, like these pattern values, right? The tracker, they were all zeroed out. So what we're actually doing here in this script, we're going to use the actual grid for some storage, right? So basically, each step, we want to evaluate each track, see whether the light is lit, and if the light is lit, we're going to send a trigger. So, rather than using pattern storage, we're actually kind of storing it by virtue of these LEDs being on. We're just going to read the LED brightness to figure out whether to send a pattern or not. Send a trigger or not. So let's go down here to the bottom of metro, and we're going to do a loop from 0 to 3, once per track. And let's fire, what's our first unused script here? 5. So if we go to number 5, basically I just want to look at each, wherever I'm at in the increment counter. I just want to see if that light is lit. If that light is lit, I'm going to send a trigger. So let's do if not 0, g.led, and t is now our time counter. And that'll be the x value, and I is actually our loop counter. So this is basically column row, right? If that's not 0, meaning if that LED is lit, then let's send a trigger. And the trigger we want to light is our loop counter. If we pop back over here, we can see that we've got some stuff happening on track number 3. And it looks like we're lighting track number 3. Not quite sure what's going on with track number 1 there. I would think that would be firing right now, but it's not. And I think that's because our loop counter is going from 0 to 3, but this isn't actually TR0, right? This is TR1, 2, 3, and 4. So let's add 1 to this. There we go. So now we should see these triggers going off along with tracks 1 and 4. Perfect. And because we can, let's go ahead and set this up for the ER301 as well. So we'll basically we can actually copy this command. Alt-C to copy, Alt-V to paste. All we need to do to enable this for the ER301 is put a SC in front of this for sound computer. I've still got my ER301 scene set up here, so let's unmute that. Cool. One other thing I want to do for the sound computer, out of the gate, the trigger times are a little bit long on it, and if you're running a fairly fast, not even like a really fast, but just kind of a moderately fast metro, you could, drop some triggers there just because the trigger times are kind of long. So let's go ahead and, in our init script, we'll do loop 0 through 3, and let's do sctr time for port I, and let's just set that to like 10 milliseconds, a very short trigger. I had already done that, I think, and so that's why we're not like really missing any beats there. But you know, you may have noticed that it like skipped some triggers or something. So that's why. And let's go ahead and save this. So we'll go ahead and go to a new scene here. I'm going to put it on scene 2 and just do, we'll call this NR Grid Visualizer. Do an Alt-Enter to write. And I think all that remains here is to kind of test it on the grid itself. Although this, you know, does actually work pretty well. You know, on the grid simulator screen, it's not too bad to work with, but let's test it for real. All right, so I'm just going to unmute the ER301. Let's go here to track 1. Let's turn off the mask. Let's go to track 2. Let's go to track 3, which is a hi-hat. And let's go to track 4 and maybe change the factor there. Maybe change the mask around a little bit. Oh, and the one thing we didn't test is to change the prime value on the fly. So that seems to be working great too. So congratulations, you figured out the NR op and built a really cool scene to go with it. So hopefully you understand that really well now. I guess where to go from here. This is definitely not the only way you could use that numeric repeater op. So for example, you know, we just set it up where each track shares the same prime. It would definitely be possible to you know, use a different prime for each track. There's nothing that really says you're limited to 4 tracks either. That was just what was, you know, kind of easy to display on the grid, and also have a, you know, control surface for each one. But you know, there's 8 outputs on the teletype trigger. You know, you could use these as triggers. You could use some additional triggers even on the Ansible if you wanted to do some more tracks. You know, I think another thing that would be interesting, like right now we're just kind of controlling all of these inputs to the NR operator with the grid. But, you know, for example, you've got an N value on your teletype, or if you have a TXI, you have, you know, actually 4 N's. So you could possibly, you know, read those and, you know, put one or more of those parameters under CV control. You know, just kind of sampling the input to those N parameters. So a lot of things you can do with these, I think. They're really looking forward to experimenting some more with them. Hope you've had some fun with it. That's all for this time. Take care. Catch you later.